So let's take a look at the last lesson of Unit 3. So once again, we've talked about decimals and dividing, and now we're dealing with fractions. And we've looked at all the different types of math that we could do with fractions outside of the book, right? And now we're back in the book, and we're finishing up the division of fractions. So once we're finished with this lesson, you have your assignment, then you're going to have your test in our next class. So going back through this, then once again, we want to know what our goal is and understand. So when we talk about the I can statement, our objective, we want to be able to divide fractions by whole and mixed numbers. So a lot of this is repeating what we did in 3.3 and 3.4. So why do we have to go back over it? To make sure we have it, right? This is stuff I need you to own and for you to be confident in as we move forward throughout the year, because there's not a lot of, hey, let's go back and let's review lesson 3 in unit 3 when we're in unit 8 and 9, but we still have to remember how to do it. So going back through it, then understanding that when we do have a whole number, we can't use a whole number, right? We can't use mixed numbers. If we're going to multiply or divide fractions, they have to be in fraction form, and that's all we can have. So if I'm going to have my 6, then a whole number just gets put over 1 each and every time. All right, so 6 becomes 6 over 1, and 11 becomes 11 over 1. What about big numbers? I had somebody ask me that the other day. What about these big numbers? Well, 123, it just gets put over 1. It doesn't matter how big or small the number is. I'm simply going to put it over 1 so that now it's in fraction form. And now we look at mixed numbers. So once again, mixed numbers is when I have a whole number and a fraction together. And once again, I can't have that when I'm doing the multiplication and division of fractions. They can only be in fraction form. Howbeit, it's an improper fraction, but that's okay because that's the only way that I can do the math. So once again, when we're doing it, then we're going to go clockwise, right? The way of the clock when you look at the second hand. But we're going to start at the very bottom with the denominator. We're going to have our 8. First step is to multiply. So I do 8 times 3 and I find their product. So their product, or that answer, is 24. Then I go from the 24 and I'm going to add the numerator that's there. 24 plus 2 is going to give me 26. And then I just simply keep my denominator. So I now have 26 eighths that I can use in the math problem. Or if I have 1 and 4/12ths, same process. I start at the bottom, start with the 12. I'm going to multiply going clockwise. So 12 times 1 is 12. And then I take the 12 and I'm going to add the numerator that is there. 12 plus 4 is 16. And I keep my denominator of 12. So anytime I see whole numbers, I'm going to put them over 1 in these math problems. Anytime I see mixed numbers, I'm going to make them improper fractions. But then I'm going to notice that I still have a division problem, division of fractions. So when I realize how to do this process, then I have to also say, well, I can't divide, so I have to do my KFC. So when I start out, I have 3/5 divided by 2. I make it 2 over 1. Right? So when I have my fractions and I see its division, then I ask, can I divide fractions? No. So what am I going to do? I'm going to KFC it. I'm going to keep my first one. I'm going to flip my second one. And then I'm going to change my division into multiplication. Once I've done that, I can go back to my original questions of multiplying fractions. Can I multiply fractions? Yes. How do I do it? I multiply across. Now, please understand, I'm not saying I'm going to cross multiply. Cross multiplying happens when I'm doing the butterfly effect to see that if I have equivalent ratios or equivalent fractions. Multiplying across means I'm going to go from numerator to numerator and I'm going to multiply. From denominator to denominator, I'm going to multiply. I say this because I had a couple of you asking me the other day how to do this, and you're not showing the arrows that I show to answer the questions. Can I multiply fractions? Yes. How do I do it? I multiply across, and every time I've worked these for the past several years of teaching 6th grade, I always show those arrows, so I know what I mean by multiplying across. So my denominators get multiplied, my numerators get multiplied. When I multiply my denominators, 5 times 2 is 10. When I multiply my numerators, 3 times 1 is 3. Then I ask, can I simplify or reduce? No, 3/10 is as low as I can go. So looking at example 1, they give us a word problem. And don't let the word problem confuse you. Once again, just read it and think about what it's saying. And we need to understand first and foremost when we're doing word problems, especially with division, that order matters. And I have to be able to figure out what the order is of the information. And the best way I'm going to do that is by, once again, cubing my math problem. So the first thing we start with is looking for numbers and labels so I know what I'm dealing with. And if the labels match, then I know I can do work with them. But if the labels don't match, then usually I can't do work with them, or I end up with a mixed label like miles per hour. So when I see my first one, it says Faye is making party favors and she is dividing 3/4 pounds of cashews. So there's a number and a label into 12 packages. So I have another number and label, right? Not really the same label. So let's figure out what I need to do. Let's see, what kind of math is mentioned? Well, we go back to the problem. It says she's dividing and into, so I know that that's going to tell me I need to be doing division in my math problem. And then when I look for my question, it's saying how many pounds of cashews are in each group. So when it comes to division, then what I'm looking for, especially using my labels, is if I have a certain amount of something, what do I have? Right? So we talked about in lesson 3.1, have, has, had, what am I in possession of? And then what are the groupings that I'm putting it into? Those are so important. Well, some of you are like, well, why is that important? Because if I don't know what I have and what the groups are, I don't know how to set up my division. Once again, in 3.1, I gave you this image and we talk about if it's in a number sentence. My first number in the division number sentence is what I have. The second one is the groups I'm putting it into. And when I put it into a division box, then I know what I have goes inside. So when I'm looking at these two equations that they give me and I'm trying to figure out which one I have to use, I have to know what I have because it has to be first. I have 3/4 pounds of cashews. My groupings is going to be in groups of 12. So when I look at the two different problems, it's saying, well, you need to circle the one that is going to give you the right math. It's going to put the 3/4 in front. And I talk about this because when you were doing last night's homework assignment on question 8, when it was talking about different weights or pounds and different colors, and you had to do purple and yellow, and you had to put it into 3/16 pound bags, many of you were putting the 3/16 in front and trying to divide by how much weight you had in the two different colors. And you weren't getting the right answers. And you knew that because the answers didn't seem logical, but you didn't know why. We have to go back to thinking about what do I have, and then what are the groups I'm putting it into. And once I've done that, then I can go through, change my numbers into proper numbers that have to be in fraction, multiplication, and division, and then go through my KFC since I can't divide. So when I look at that I have a whole number of 12, I put it over 1. Now I can rewrite my problem so I can see it clearly. I have 3/4 because that's what I have in my cashews, and I'm dividing it into 12 equal groups, so I'm 3/4 divided by 12 over 1. Can't do that math, so I have to change it. So I keep my first one, I flip my second one, so it becomes 1 over 12, and then I change my multiplication, or my division, into multiplication. Now, can I cross reduce? I can cross reduce, or some of you are telling me, well, cross reducing, there's just so many more steps. I don't think that's true, right? But if I'm left with multiplication and I don't want to cross reduce, then I have to ask myself, how do I multiply fractions? And I do that by multiplying across. So if you prefer to do that, then you can multiply across. But I prefer to cross reduce. I like to work with smaller numbers. Therefore, I cross reduce. And I see that 3 and 12. Oh, 3 will go into 12. 1 plus 2 is 3. So yeah, 3 goes into 12. Therefore, I'm going to reduce top and bottom by 3. Well, 3 goes into 3 one time, and 3 goes into 12 4 times. Is there anything else I can cross reduce and get even smaller numbers? Nope, that's as far as I can go. So I know now what I'm left with. Now I can do my cross, multiplying across. So I have 1 times 1 and 4 times 4. 4 times 4 is 16, and 1 times 1 is 1. So we have 1/16. 1/16 what? What are we talking about? Well, before we look at a label to figure out what we're talking about, I'll have some of you are like, well, why can't I just do it in both ways, right? If I'm adding, I can have it in any order. If I'm multiplying, I can have it in any order. Wouldn't it be the same with division? Well, let's see. Let's go ahead and try it. Let's say, no, I'm going to keep that second one. I'm going to start out and I'm going to make it 12 over 1. So now that I have 12 over 1 divided by 3/4, and I know I can't divide, so I'm going to take 12 over 1 and I'm going to keep it. I'm going to flip my second fraction, so that's going to be 4 over 3, and then I'm going to change my division into multiplication. Will that give me the same answer? Well, let's see. If I cross reduce, I have 4 on top and I have 1 on the bottom, and then I'm multiplying straight across to get to my answer, right? So when I'm multiplying across, what do I get? This is running really slow for some reason. I end up with 1 times 1 in my denominator, which is 1, and 4 times 4, which is 16. So what we're saying is I only have 3/4 pounds of cashews, and I'm going to put them into 16 different packages? Does that make any sense? No, that doesn't make any sense at all, right? So when I'm thinking about the math that I'm doing and I get to my answers, once again, I have to think logically. How many pounds of cashews are in each package? If I had 3/4 of a pound of cashews and I put it into 12 individual packages, then I end up with 1/16 of a pound, right? So there's not going to be very much in that little itty bitty portion left over for the packages, but it's enough to make some people happy, right? If I end up with just 16 packages and each of them have 3/4 of a pound, well, that doesn't make any sense, right? So when I get to my answers, I have to stop and think logically. Is my answer making sense? What do I have in order to do the math? And what are the groupings that I'm going to put it into, right? So if I know the order and I know I'm dividing the have by the groups, then I know that I can get to my right answer. I can only do the one that's on the left, right? The one on the right, it doesn't make any sense because I end up with a crazy answer that I can't have. So then what is my label? Well, once again, I underlined it in yellow just now. How many pounds of cashews are in each package? So therefore my label is just simply pounds. Now some of you, you're writing on your assignments, pounds of cashews in each package. You can. I'm never going to count that wrong. I'm just telling you, you don't have to. It's more work than I expect. I just want you to know that you have 1/16 of a pound. So before we get into more complicated ones, let's go ahead and have you do this one. Give it a shot. Pause the video, come back, and let's check your work. So hopefully you have an answer. And one of the things that you did was you cubed your question. You notice that we have 3/4 yards that we're talking about, and then we have 6 pieces that we're looking to have it separated into. We also focus in on the word into, and that tells us that we're going to be dividing. So if I look at that, then I look at underlining the question and notice that there are 2 things that we're asked to do. First, it tells us to write, and then it tells us to solve the equation. I bring that out because there are some of you that you're not doing both parts of a question, or you're not really underlining the question you're being asked at all, and you end up with a weird answer. Several of our past assignments have been, well, how much is left? And you're giving me the total amount of groups they can put them into. So as you did this then, hopefully you set it up and you realize that the 3/4 of a yard is what you have and that you're putting it into groups of 6. So when you start out the original equation, we have 3/4 divided by 6. But then once again, we realize we can't just use 6 by itself, so we put it over 1. Then we ask ourselves if we can divide fractions, and no, we cannot. So we must change it. We must go through the KFC process. We keep our first one, our second one, we're going to flip. It says flip the second fraction. We find our reciprocal, and that is 1/6. And then we change division into multiplication. Once again, I want to work with as small as numbers as possible, and I see if there's anything diagonally to each other that I can cross reduce. And I notice that 3 and 6, that 6 is a multiple of 3. So I can reduce both top and bottom by 3. Reducing, once again, is always to divide by the exact same number, a numerator and a denominator. So I'm going to take 6 divided by 3 and 3 divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Then what I'm left with is simply multiplying across. I'm left with multiplication of fractions, which I can do, my numerators and my denominators. So I take 4 times 2, which is 8, and 1 times 1, which is 1. Now, it's a word problem, so I have to look for the proper label. It's important that I have the correct label, right? So when I start looking at it, don't get caught up and say, well, it must be pieces, because it asks me to find the length of each piece. Length is a measurement, so therefore it's got to be 1/8 yard as my final answer. We got this? All right, so let's look at some more problems where we're dealing with mixed numbers as well as our fractions. So once again, on mixed numbers, I've taught this several times, and if you haven't learned it yet, then I advise you to take some notes. Please understand, though, that this image over here on the left is on your Canvas announcements, and you can look at that at any time you need to remember how we create going from a mixed number into an improper fraction. So if I have 2 and 1/4, I have to start at the bottom, always start at the denominator. I'm going to go clockwise once again. So I'm going to multiply going clockwise 4 times 2, and I get the answer of 8. Then I always add whatever the numerator is to that product. 8 plus 1 is 9, and then I simply keep my denominator. So I end up with the first fraction being 9/4. I keep everything else, so 9/4 divided by 2/3. Can I divide fractions? No. So I have to KFC it. I keep my first one, I flip my second one, so I use the reciprocal of 3/2, and then I change division to multiplication. What can I cross reduce on this one? Well, nothing. So I'm simply going to multiply across. When I multiply my denominators, 4 times 2 is 8, and my numerators, 9 times 3 is 27. Now, it's top heavy, therefore I have to change it, right? I have to take the top off of the convertible card. So we're going to convert it. Top number always goes inside the box. I'm dividing by the bottom number, and 8 will go into 27 3 whole times, because 3 times 8 is 24. When I find my remainder, I end up with 3. And as always, my remainder is my numerator, my divisor is my denominator. So I end up with an answer of 3 3/8, which is indeed what the book says that we should have. All right, moving on. When I look at this next problem then, once again, just going through the same processes, notice I have a mixed number and a whole number. It's okay, we know how to do both of those. So I take my 3 1/3, I start at the bottom, I go clockwise, I'm going to multiply and add. I have 3 times 3, which is 9, and then I add the 1, which is 10. I keep my denominator of 3. And then when I have a 6, I simply put it over 1. So now I make sure I put them back in the correct spots when I rewrite the math problem. So I have 10/3 divided by 6/1, and then I can't divide, so I KFC. I keep my first one, I flip my second one, so the reciprocal is 1 to 6, and then I change division to multiplication. Can I cross reduce? I can, because 6 and 10 are both even, and therefore I can reduce by 2's. And so when I reduce by 2's, I have 10 divided by 2, which is 5, and 6 divided by 2, which is 3, and then I'm left with simply multiplying across. 5 times 1 and 3 times 3. So 3 times 3 is 9, and 5 times 1 is 5, and I find out that 3 1/3 divided by 6 is 5/9. All right, and then we go to 2 1/2 divided by 3. So I would like you to try this one on your own. Come back and check. Let's see how you do. So hopefully you just followed the same pattern that we just did on the previous one. You took your 2 1/2 and you changed it into an improper fraction. You started at the bottom, multiplied, 2 times 2, which is 4, and then you added your numerator, you got a numerator of 5, and you kept your denominator of 2. You take your whole number and simply put it over 1. So once you've done that, then you should start by rewriting the math problem. If we skip that and we try to just go ahead and change that into multiplication, then a lot of times 6th graders just simply mess it up. It's not just 6th graders that do it. The older students and even adults will do it wrong. So don't try to skip steps. Just fill in the steps and follow those steps, and you'll be okay. So when I know I can't divide, then I go through my KFC. I keep my first one. I flip my second one, so my reciprocal is 1/3, and then I change my division to multiplication. I'm left with multiplying across, and when I multiply across numerator and denominator, 2 times 3 is 6, and 5 times 1 is 5. There's no labels, it's not a word problem, so 5, 6 is my final answer. What about when I have two mixed numbers? It's okay, I still do the same math. If I have two mixed numbers, I have to create two improper fractions. So if I have 4 2/3, I start at the bottom, I multiply and add. So 3 times 4 is 12, plus 2, it gives me 14. I keep my denominator of 3. And then I have 1 3/4. I'm going to start at the bottom, multiply and add. 4 times 1 is 4, plus the 3 is 7, and then I keep my denominator of 4. So I rewrite my problem so that I see I have division, 14/3 divided by 7/4, which I can't do, so I KFC it. I keep my first one, I flip my second one, so I use the reciprocal of 4/7, and then I change division to multiplication. I check to see if there's anything I can cross reduce. 3 and 4 can't, but 14 and 7 can. 7 will go into both of them. So since 7 will go into both of them, I want to reduce by 7. 14 divided by 7 is 2, and 7 divided by 7 is 1. So now I'm left with just simply multiplying across. 3 times 1 is 3, and 2 times 4 is 8. Then I have to convert it because it's top heavy. It's an improper fraction. Top number goes inside the box. I divide by 3. 3 will go into 8 2 times because 2 times 3 is 6. I have a remainder of 2. And once again, my remainder is my numerator. My divisor is my denominator. So I end up with a final answer of 2 2/3. Just like that previous one, I would like you to try this one on your own and then check your work. Let's see how you do. So hopefully you realize you have to change both of those into improper fractions. You have 2 3/8. You started at the bottom, you multiplied and got 16, and then you added and got 19, and you kept your denominator of 8. Then with the 1 1/4, you started at the bottom, you multiplied, you got 4, then you added and you got 5. You kept your denominator of 4. Hopefully you set up your new math problem then, which is 19/8 divided by 5/4. You said, well, I can't do that, so I have to KFC it. You kept your first one, you flipped your second one, and then you changed to multiplication. Hopefully you saw that you can cross reduce because 4 and 8 can be reduced with one another. If I do that, then I'm going to reduce by 4. I could do 2's, but then I could reduce by 2's again. So if I do it in one step, I have 8 divided by 4, which is 2, and 4 divided by 4, which is 1. And then I simply multiply across. I have 19 times 1 and 2 times 5. Well, 2 times 5 is 10. 19 times 1 is 19. Improper fractions have to be converted, so hopefully you divide it and put your top number inside the division box. Dividing by 10, you know it will only go in one time, which gives a remainder of 9, and then you made that your numerator, and your bottom number is the 10. Your divisor is your denominator. Did you get 1 9/10? If you didn't, then let me know and ask some questions and I can help you. If you did, well, good job. Time to move on. So this one has many steps to it. This is where, if we will cube our questions, then we eliminate a lot of problems that we might have. So when I start, once again, on cubing, I circle any of my numbers and labels. So I have 35 3/4 yards. I have 30 1/3 yards. Now, some 6th graders in the past would just jump in and start dividing those, but I really need to read what's going on. Miley has 35 3/4 yards of red ribbon and 30 1/3 yards of green ribbon. So those are both the have categories. She cuts the red ribbon into strips that are 3 1/4 yards long, and the green ribbon into strips that are 2 1/6 yards long. When I start looking at the word into, then I know that's division. So understand that I have two halves and I have two groupings, and they're all the different numbers. So when I'm looking at what I'm being asked to do, it tells us that we want to figure out how many more green strips than red strips she has. So I have to start by separating them and doing two different problems before I do the third problem to find out how many more. So I changed the color so we can focus in and see what the reds are that are matched up according to the question and what the greens are that are matched up. So we're going to start with the red, 35 3/4 divided by 3 1/4. We have to make both of those improper fractions. So we start at the bottom, we go clockwise, we multiply, and then we add. So 4 times 35. Well, this is where your handy dandy calculator comes in handy. I multiply 4 times 35, and what I find out is that that's 140. And then I add the 3, and I get 143 and keep my denominator of 4. Then when I take 3 1/4, I start at the bottom, I multiply, and then I add. So 4 times 3 is going to give me 12, and then I'm going to add 1 and give me 13, and I keep the denominator of 4. So I make sure that I put them in the correct spot underneath the 35 3/4. Notice we have the 143 over 4. Underneath the 3 1/4, we're going to put the 13 over 4. Now I have a division of fractions problem, and we say, well, I can't do that. So I need KFC. I keep my first one, and I'm going to flip my second one. So instead of 13 over 4, we're going to have 4 13ths and see if I can cross reduce. Well, I can cross reduce. Oh, by the way, we changed division to multiplication. But can I cross reduce the big ones, 143 and 13? Well, the easiest way to find out is you pick up your handy dandy calculator, you type in 143, divide by 13, and see if that gives you an even number. By the way, it will. So I can reduce both of these by 13 and work with much smaller numbers, which is always going to give me a better chance of getting the correct answer. So when I do 143 divided by 13 on my calculator, it tells me that that is 11. And then 13 divided by 13, any number divided by itself is 1. And then notice the 4s, any number divided by itself is 1s again. So now I have multiplying across. I multiply 11 times 1, which is 11, and 1 times 1, which is 1. So what we're saying is, when I do this, I end up with 11 strips of red ribbon. That's not the answer. Now I have to do the green. I have 30 1/3 yards of green, and I'm going to put it into strips that are 2 1/6 yards long. So I have to change both of those into improper fractions. 30 1/3, I start at the bottom. I multiply going clockwise, and then I add. 3 times 30 is 90, plus 1 is 91. I keep my denominator of 3. 2 1/6, I start at the bottom, I go clockwise, multiply and add. 6 times 2 is 12, and then 12 plus 1 is 13. I keep my denominator of 6. I put them in the correct corresponding places, so I end up with 90 1/3 divided by 13/6, which I can't do. So we KFC. I keep my first one, I flip my second one, I use the reciprocal of 6/13, and then I change division to multiplication. What can I cross reduce? Well, once again, if I don't know if 13 will go into 91 or not, I simply pick up my handy dandy calculator and I check. I take 91 divided by 13 and see if it goes in an even number of times. And it does. So I'm going to cross reduce both of them by 13. 13 goes into 91 as we just saw 7 times, and 13 goes into 13 one time. What about 3 and 6? Yep, I can cross reduce those as well. 3 will go into 3, and 3 will go into 6 evenly. So when I cross reduce those, 3 divided by 3 is 1, and 6 divided by 3 is 2. Now I simply multiply across. I end up with 1 times 1, which is 1, and 7 times 2, which is 14. Now we know we have 14 green strips. And that's still not my answer, because my question is, how many more green strips do we have than the red? So in order to do that, I have to subtract them. So if I have my 14 green strips and I take 11 red from it, then I know that I have 3. 3 what? Strips. Now, that's all I need as your answer, but if you want to be more specific, you're more than welcome to be more specific. You can say 3 more strips, or you can say 3 more green strips. As long as you get to the right answer, that's what I care about. All right, so that's our lesson, and that combines everything together, and that's the last one before we get into our test, which will be in our next class. So, as you're doing it, please take your time, follow the steps, and if you have questions, please come and ask me. I'm here to help.